Friends, I am Dr. Gajanan Wagh, Head, Department of Chemistry, Rayat Shikshan Samsthan's SM Joshi College, Hadapsar, Pune. I am teaching subject Physical Chemistry. You have 6 theory papers: Physical Chemistry, Inorganic Chemistry, Organic Chemistry, Analytical Chemistry, Industrial Chemistry, and Environmental Chemistry. Out of that, in the TY third year BSc Chemistry, Savitribai Phule Pune University syllabus, in this Physical Chemistry paper first, there are 4 topics. First topic is Chemical Kinetics, second topic is Electrolytic Conductance, third topic is Investigation of Molecular Structure, fourth topic is Phase Rule. Out of that 4 topic, I am going to start the second topic. The name of the topic is This is the second topic, electrolytic conductance. Now, dear friends, there are some important 5 to 6 definitions. So that definitions are very important to understand the electrolytic conductance topic. Which are the definitions? First definition is conductance, then Ohm's law, then specific resistance, then specific conductance, then equivalent conductance, and then cell constant. These are the 6 definitions which are very important to you to understand this whole electrolytic conductance topic. So I am going to discuss the one by one these 6 definitions. In these definitions, there are some equations, very simple equations, which are like 8th and 9th standard. I know that some students are without mathematics. Mathematics not in 12th, mathematics not in first year, not in second year. But I will explain very easily, very simple equations, and I will going to repeat it. Then you will easily understand. Now, one by one, we will see the definition. So, what is meant by conductance? First definition, conductance means you know that there is a conductor in the bus. If you ask the student, what is the duty of that conductor? Student will say, to cut the tickets. But it is not a duty of conductor, it is a part of duty. Then what is the duty of conductor? Why he called as a conductor? So his duty to carry the passenger from one place to another place. To carry the passenger from one place to another place is the duty of conductor, and therefore he called the conductor. And same definition is applied here for the conductance. Means to understand the definition conductance. Conductance means the solutions which contain the ions in between the 2 electrodes. For example, this is the electrode. This is connected to the negative electrode, this is connected to the positive. This is the one electrode, positive electrode, negative electrode, which is fixed in a tube, and this is the electrolyte solution. electrolyte solution. This is nothing but electron. So these two electrodes are at a fixed distance, means length of this electrode is L centimeter. Length between the two electrode is N centimeter. Is nothing but the length of this solution is a conductor. Length of this conductor. Length between the two electrode is nothing but the length of the conductor. So when you apply the electric field, then the ion moves. Suppose in the solution there is a positive ion which will move to the negative electrode and negative ion which will move to the positive electrode. Moment of the ion takes place. And these ions moves which carrying the current. Like a conductor carrying the passenger from one place to another place, and these ions carrying the current from one electrode to another electrode, means one place to another place. And therefore it is called as a conductivity, ability of ions or tendency of ions to carrying the current through this electrolyte solution in between these two electrodes is called as a conductivity or conductance. Okay, this is about the conductance. Now if we are going to understand the conductance and further in detail, we require the Ohm's law. So second is Ohm's law. What is meant by Ohm's law? So this solution is nothing but the conductor. This electrolyte solution is nothing but the conductor. Ability of ion to carrying the current, or ability of cation anion to carrying the current, or ability of solution to carrying the current is nothing but the conductance, and that solution is called as a conductor which is in between the two electrodes. Okay, now what is meant by Ohm's law? This is also important for this conductometry chapter. Ohm's law is nothing but when the current I passing through the conductor, this is also conductor, metallic conductor or solution conductor, electrolytic conductor. So current I flowing through the conductor is directly proportional to potential applied and inversely proportional to a resistance of that uniform conductor. So this is the Ohm's law. Once again see, I is the current flowing through this conductor is directly proportional to the potential or EMF applied and inversely proportional to the resistance. So I is current measured in ampere, E is the potential measured in volts, and R is measured in ohms. R is resistance measured in ohms, E is the potential measured in volts, current I is measured in ampere. Means if this potential is a constant, means E is equal to constant, then this I is equal to 1 upon R. This I is equal to 1 upon R. And this R is the resistance, and 1 upon R is called as a conductance. Conductance. 1 upon R is called as a conductance. It is denoted by C or it is denoted by K. In different book, notations are different. So 1 upon R is nothing but the conductance of a uniform conductor. Conductance of a uniform conductor. Now these are the 2 points, conductance and Ohm's law. Now what is the unit for this conductance? So unit for this R resistance is ohms. So 1 upon R, conductance I is equal to ohm inverse. Ohm inverse is the unit of that conductance. Now third definition, next definition is specific resistance. What is meant by specific resistance? These are very simple one sentence definition, but very important to understand the whole topic. Very important in the problems, solving the problems. So what is meant by specific resistance? Suppose rho, it is denoted by rho, or some it is denoted by this symbol, or some it is denoted by R. R, rho, sigma, these are the notations which are used by the different books. But you remember one, rho is nothing but the specific resistance. So these are the two electrodes, negative electrode, positive electrode. Specific resistance, we are going to study the specific resistance rho, denoted by symbol rho. So these are the two electrodes, negative electrode, positive electrode, metallic electrode. Solution liquid, this is the electrolyte solution. So this length of the conductor is L centimeter. Length of the length is equal to L is equal to centimeter. Okay, and this is the electrolyte solution is a good conductor. So this is the cross sectional area A of this conductor, which contains the positive ion and negative ions. This is the A, is the cross sectional area between the two electrodes is nothing but the cross sectional area of uniform conductor is A. That is a electrolyte solution which having the capacity to carry the current. It contains ions, positive ions and negative ions. According to the conductance topic, substances are divided into two categories. One is called as the electrolyte solution and another is called as non-electrolyte substances. The substances which have ability to conduct the electricity are called as the electrolyte solution, and substances having no ability, not conducting the current, is called as a non-electrolyte substances. So this is the electrolyte substance, electrolyte solution. Okay. Now this distance between these two electrodes is L, means distance of the length of the conductor is L. And cross sectional area, this is the cross sectional area. This cross sectional area is of a conductor is A. Area, cross sectional area A, centimeter square. This area is measured in centimeter square. Now what is meant by specific resistance? Remember, very simple equation. So resistance R, this is the resistance R of a uniform conductor. This solution is nothing but the uniform conductor which carry the current, which conduct the electricity, which carry the ability to carry the electricity. Therefore it is a uniform conductor. So resistance of this uniform conductor is directly proportional to L and inversely proportional to A. Remember, this is the length between two electrodes, is the length of the conductor. A is the cross-sectional area of that uniform conductor. So resistance of that uniform conductor is directly proportional to L and inversely proportional to A. Very, very important equation. Remember it. Now to remove this proportionality sign, this you can write R is equal to rho into L upon A. This is equation 1. R is that. This is very simple. You can understand. If you change the length, conductance will change. Means this resistance of that conductor, resistance, remember resistance, not specific resistance, resistance of this conductor is directly proportional to L and inversely proportional to A. Means directly proportional to length and inversely proportional to cross-sectional area. So remove this proportionality sign, add the proportionality constant. Rho is called as a proportionality constant is equal to specific resistance. Is a specific resistance. This rho is called as a specific resistance. Now rearrange this equation, you will get the specific resistance. So rho is equal to, you have to find out the specific resistance. So rho is equal to, R remains as it is, this equation L upon U will get multiplied to R. So R as it is, we are finding, therefore we are finding rho from equation 2. So rho is equal to R into, this will change when it comes to this side. Numerator and denominator will change. Denominator will go on numerator, numerator will come on denominator. So it will be A upon L. This equation 3 is nothing but the equation of specific resistance. This equation is called as a specific resistance. Rho is a specific resistance. Rho is a specific resistance. R is directly proportional to L upon A, length and cross-sectional area. Remove this proportionality sign, add the proportionality constant rho, rearrange the equation. So rho is equal to R into A upon L. This is nothing but the equation of specific resistance. Very, very important. Once you understand specific resistance, you will understand specific conductance. You will understand equivalent conductance. You will understand cell constant. Okay? So, only remember this equation. Only remember this equation. R resistance of a uniform conductor is directly proportional to L upon A, or directly proportional to L and inversely proportional to A. Remove this proper side, add proportionality constant is the specific resistance, and rearrange the equation. Rho is equal to R into A upon L. So this is the equation for specific resistance. Now, what is the unit of this? Unit of this equation. Unit for specific resistance. So, rho, unit for the rho. So, R is measured in ohms. R is measured in ohms. Area is measured in centimeter square. And length L is measured in centimeter. So this centimeter will get cancelled with this centimeter, and the unit is ohm centimeter. This is the unit for rho, specific resistance. Unit for specific resistance, because rho is nothing but R into A upon L. So rho is a specific resistance, R is in ohms, A is in centimeter square, L is in centimeter. This will get cancelled. Ohm centimeter is the unit of specific resistance. Now, if this L is equal to 1 centimeter and A is equal to 1 centimeter square. These electrodes are at a 1 centimeter length and this area is 1 centimeter square and L is length is 1 centimeter fixed. Then what will be this equation? This equation 3 will be rho is equal to R, because 1 divided by 1 is equal to 1. So rho is equal to R is nothing but equation 4 is nothing but the specific resistance is the resistance of a uniform conductor when the length of the electrode is 1 centimeter apart and cross sectional area of the conductor is 1 centimeter square. Okay.